Students, this is Unit 7, Lesson 7.4, Undercover Right Angles. You're right here in your preview note. Don't forget to get a date, time, location, as well as a parent-guardian sign-off. Do not think you can multitask and do this at the same time. Please turn off all distractions and focus on the task at hand. Students, you should have Post-its handy for this page. You should have Post-its handy. Let me start by labeling and giving you a little push in the right direction. Then you're going to pause the video, do your own work, and restart. So let me color code this for you. We are told that measure of angle 6 is 40. So from here to there, that's an angle, is 40 degrees. We're told that measure of angle 4 is 60. So from there to there is 60 degrees. And we are told that the measure of angle 15 is 50 degrees. Knowing this, you want to find all possible angles. So here's your one hint in doing this is darken all your ons. Those are all your on points. Where there is an on, you are using your Post-it notes. And where you use your Post-it notes, the equation is angle equals arc over 2. Wherever there's an on, that's where you use your Post-it notes, and your equation is angle equals arc over 2. Try to do this completely on your own. I've made the number simple. Pause the video, restart when you're done, have a red pen handy. Okay, students, you should be switching to a red pen and correcting. Remember, you are correcting, not copying. So right here, if that's 50, right out here should have been double. That's 100. If this here is 60, we stretch this out. That's 120. And then we keep going. If that's 40, this arc from here to here is 80. And then to get our last little bit here, you should have added, do the math, 100, 120, 80, 300, and of course you get this last one to be 60 degrees. Knowing that, once you have all your arcs, you just keep working the halves. That half right there is 30. This, going back this way, is half of the 80, so you should have 40 here. That's half of 60, so that's 30. The 1 is half of 120, so that's 60. The 2 is half of 40, so that's 40. The 3 is half of 100, so that's 50. So now we have all our on angles, and then you should have physically traced. This angle in the middle is a chord. And that is going to be angle equals, which is both 10 and 12, arc plus arc over 2. So arc plus arc over 2. So our arc here is 60, our other arc is 120. And we divide by 2. We get 180 divided by 2, and you just figured out that this middle is 90 degrees. Now it's not drawn to scale. Which, if you check these triangles in the middle, you simply add the two angles, take away from 180, you would see that all four of these triangles now add up to 180. The only arc left is angle 8, and 8 is secant, and you sweep that out. That's going to be big arc 120 minus little arc 80. It's going to be 40 divided by 2. That means angle 8 should be 20, folks. 20. You will see that again and again in class, finding all angles. So you start by watching all the ons, and where there's an on, there's a post-it. Okay, today we're going to talk about circles, and we're going to specifically focus on the one single concept of tangents. You're really going to need a straight edge today. We're going to talk about tangents, radius, chords, the tan angle, tan chord, and of course a right angle. So I want you to imagine, I'd just like you to physically trace this straight line, physically trace it, write the word ground. And imagine this wheel turning. Now, I'd like you to trace a spoke in the wheel. Now imagine that wheel turning. Okay, and when that spoke physically touches the ground, I'd like you to trace that spoke and the ground. Now ready? Using a straight edge, I'd like you to trace the ground. Now trace the spoke that is tangent to the ground. Remember, tangent means to touch. Tangent to the ground. Ready? I'd like you to do that again, folks. I'd like you to trace the ground. And I'd like you to trace the spoke that is tangent to the ground. I think you can instinctually feel what kind those segments, that radius and that tangent to the ground, I think you can instinctually feel that they are perpendicular. So anytime you have a radius touching, remember touching means tangent, there's going to be a right angle, a radius and a tangent. And that's true whether it's a radius or go all the way across. All the way across. Let's label it. That right angle is true whether or not it's just a radius, bracket that. Or whether it's a diameter. That's really critical, folks, because you're going to see that a lot of what you're doing for the next class is simply undercover right triangle stuff. So it's super important you can find that right triangle. Right triangle undercover. Using a straight edge, please. I'd like you to trace that radius. Darken that point. Now using a straight edge, I'd like you to draw a tangent. Ready? I'd like you to put your finger here. We're going to sing this little jingle. It's going to help you remember something. First, you're going to learn the jingle. It's to the tune of Mary Had a Little Lamb. So Mary had a little lamb, little lamb, little lamb. Mary had a little lamb whose fleece was white as snow. That's what you're singing. Ready? Sing first with me. Put your finger right there. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. Sing it one more time. It is so critical that you get this stuck in your head. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. Now, I'm going to make you do double time. I'd like you to physically trace and sing what you are tracing at the same time. Ready? Watch carefully. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. One more time. We're going to put the right angle on the other side. I'd like you to trace and sing Sing and trace. This will get it stuck in your head. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. So wherever there's a tangent and a radius meeting, there's a right angle. And that's true whether it is a radius or whether it's also a diameter all the way across. Okay, so here's an example. Let's trace this and circle O, so darken O. O is the center of the circle. AB is a diameter. Let's trace it. AD is a tangent. Let's trace that. I recommend with a straight edge. Find and mark all known right angles. I'm going to just pause for about 30 seconds here. You don't need to stop the video. I'm just going to stop talking. Your job in that one diagram is to spot as many undercover right triangles as you can and mark it. 30 seconds of silence. Go. All right, let's see how you did. Ready? Let's sing. Is tangent to a radius, 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 if tangent to a radius, right angle at the edge. So there's a right angle there and a right angle there. Now you think you're done, but you need to remember your previous lessons. Ready? Let's trace A, CB. You see how that grabs this arc? Trace it. That's an inscribed angle. So if out here is 180, watch out for that right angle for an inscribed angle in a half a circle. That's also 90. So question, did you get all three of those? Really? Let's mark it on. Ready? You want to mark all right angles that are undercover here. I'm going to pause again for 30 seconds, see what right angles you can find, and then I'll show them to you. 30 seconds of silence. All righty, guys, let's see how you did. Ready? You should have done this. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. So there's one there, one there. You look for diameters and scribed angles. You don't have any. But now I want you to shade, looky there what you have, folks. Shade it. Shade it, shade it, shade it, shade it. Oh, man, you got yourself a right triangle. Now remember, whenever you have a right triangle, there are 5 things you can do with right triangles. Let's list them. Have 2 sides, need 3rd side. Tag. 45, 45, 90. Leg, 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 root 2. 30, 60, 90. Short leg, root 3, short leg times 2. So, ka, toa. And inverse SOHCAHTOA. All messy there under the cosine. Let's try that again. So keep in mind, every single time you see a right triangle, one of those 5 things might be going on. Ready? Once again, in this diagram, I'd like you to try to spot and mark any right angles. You have 30 seconds. All right, for this one, your tangent is actually this line, R to S. We're going to stretch it out. This is where straight edge comes in handy. Both of those are tangent to a radius, radius of tangent to a radius, right angle at the edge, right angles there, right angles there. Once again, a right triangle, a right triangle. Alrighty, guys, let's physically trace. We want to trace the radius Q to R. Now we're going to trace Q to T, which is also a radius. I want you to trace R to S. And trace QR again. We want to find X, which is right here. Let's see what we can do so far. We have a tangent. We have a radius. Sing with me. If tangent to a radius, radius, if tangent to a radius, right angle at the edge. So we got ourselves a right angle. The minute you see a right angle, you should be hunting for right triangles. Let's shade it and pull that right triangle out. Physically darken each of the corners. Okay, let's bring what we do have. That's 12. That's our X. Now, very slowly, I'd like you to squiggle Q to S. Very slowly here. I'd like you to squiggle Q to S. Very slowly over here, I'd like you to squiggle Q to S. You need that, obviously. Squiggle Q to S again, very slowly. I'm going to pause here about 20 seconds to see if you can figure out what that length Q to S is without my help. 20 seconds, you find it. Alrighty, guys, look very closely. Let's see what you did. If that is 12, that's a radius. From here to here is also 12. And then we know from this edge to that edge is 8. So we figured this whole thing is going to be 12 plus 8. And you have 20. Now, this is no longer a circle problem. It is a right triangle problem. This is no longer a circle problem. It is a right triangle problem. Have 2 sides, need third side. Pythag. Let's write down your equation. Leg squared plus leg squared equals hypo square. Let's circle, plug, chart very carefully. Alrighty, friends, we are going to do this without a calculator because you are smart like that. Okay, so we have 144 plus x squared. By the way, that was 12 squared equals, if you don't know what 20 times 20 is, we're going to go like this. That's 400. All right, let's solve. All right, we're going to square root here. And if you don't know offhand what this is, we're going to go ahead and factor. So I have 2 and 28. Divide by 2 again. Count your pairs of 2s. You have 1 pair, 2 pair, 3 pair, 4 pair. So on the outside, we're going to bring 4 2s out. So that's going to be 2 times 2 times 2 times 2 again. 2 times 2 is 4. Times 2 again is 8. Times 2 again is 16. So we just figured out that 16 times 16 is 256. So x equals 16. Now there's one other property with tangents that you should be familiar with. I want you to imagine yourself holding a beach ball. So imagine this is you in your head, and these are your arms, and you are holding a beach ball right here. There's your hands. You're holding a beach ball. Okay, so your head is right here, and your arms are both tangent to the beach ball. In other words, you have a tan-tan angle going on there. I'd like you to physically trace one arm, physically trace the other arm. I think you notice that the arms touching the tan-tan, if you will, that on either side, those arms are of equal length. So angle DCB is a tan-tan angle. And the arms of a tan-tan angle are always congruent. In other words, if you see something like this, physically trace from here to here, there's one tangent. Now trace there, there's another tangent. This rule says from vertex to point of tangency, vertex to point of tangency, trace, trace, hatch mark, those are equal. So if you were to solve for x here, it would simply be 4x minus 9 equals 15. Why don't you solve? So x is 6, and of course you check it, and we have ourselves 15 and 15. So the arms of a tan-tan angle are of equal length. Okay, students, for this problem, colors really, really, really make a difference. So I'm going to be using colors here, and I recommend you follow along and use colors. So we're going to trace A to E. Now trace A to D. Use the same color. Mark it congruent, because they are. That's a tan-tan angle. Tan-tan angle. Now I'd like you to trace B to E and trace B to F. That's another tan-tan angle. Mark it congruent. Now I'd like you to trace CF, point of tangency, and CD. That is another tan-tan angle. Your goal in this case, knowing what's equal, your goal is to find the perimeter, mark it all the way around, mark it all the way around, the perimeter of this triangle. I'm going to wait for a full minute, and I'd like you to try to find the perimeter of that entire triangle, keeping track of those hatch marks. That will tell you something. You've got a minute. Go. All right, let's see how you did. So you should have noticed if this is 6, that is 6. If this is 4, that is 4. And that if this is 7, that is 7. So now you simply walk it around. This whole side is 10, 11, 13. So 10 plus 11 plus 13. You have 34 units is your perimeter. Now let's see what else I want you to do. It says you're going to draw on the radii G to E. Using a straight edge, please. G to E. G to D. And G to F. Now I'm going to give you another minute, and I'd like you to try to find all possible angles in this diagram. Try to find all possible angles in this diagram. Go. Okay, these are the angles that are possible. We have a right angle there, a right angle there, a right angle there, a right angle there, a right angle, and a right angle. If you have no other angles there, folks, you cannot find the other angles unless you're provided with one. What you have to watch out for is that is a quad, so that will add up to 360. Another thing you want to watch out for is that this central angle will equal the arc, but you do not know that those arcs are equal, nor do I give you any arc measures, because the only angles you can actually find here are the right angles. Now I'd like you to go back and summarize what were some of the key things you learned today. Take 2 minutes, summarize them, and be ready to explain them in class.